In this lecture, we'll see the syntax for defining classes and creating objects. A new class is created by writing the classes statement. First, we write the keyword class and then the class name. Conventionally, the class names begin with a capital letter and are generally singular nouns. If there are multiple words in the class name, then they are joined using the camel case convention, where the first letter of each word is capitalized. After the class name, we put the colon. This line is followed by an indented block of statements which form the class body. As in a function definition, all the statements inside the class definition are also indented. Right now, we don't want to add any data or code to this class. We want to make just an empty class. So we'll write this pass statement here. So we have a simple class definition here. Let us execute it and see what happens. So Python has actually created a class object and assigned it to this name person. This is similar to what happens when a def statement is executed. You can see ID of this class object. So like everything else, classes are also objects in Python. They are called class objects. Now let's see how to create instance objects from this class. We can instantiate a class object by calling it like a function. That is by putting a pair of parentheses around it. So when this will be executed, an instance object will be created whose type will be person. Now we assign this object to this name P1. So this name P1 refers to an instance object whose type is person. Let's create one more instance object. So this is another instance object of type person. Now let's execute it. We can see type of P1 and P2. So they're objects of type person. Let's see their IDs. We can see these are two different objects in memory. Both are of type person. P1 is a person, P2 is also a person. Now let's print these objects and see. These values are the addresses in hexadecimal. Here the numbers are printed in decimal. So we have seen how to define a class and how to instantiate it. But the class that we have created is useless as it does not have any data or methods. So first we will add two methods to it. For that we will write two def statements inside the class. We'll write another def statement. So these are methods. These definitions of methods look like function definitions, except that we have this parameter self here. We'll talk about this parameter in a little while. So you can think of methods as functions that reside inside a class. To call a method, we'll write the instance name followed by a dot and the method name. So let's call these methods here. So we have called these two methods display and greet with this object P1. Now let's call these methods with object P2. Let's run this now. So this is how we can execute the methods using instance objects. Now you must be wondering how this code executed without any error, because both these methods have one parameter each. But while calling these methods, we did not send any argument corresponding to this parameter self. This worked because when a class method qualified with an instance object like this is called, Python automatically sends the argument for this parameter self. To see what value Python sends for this parameter, let us print self parameter inside these methods. Let's run this. So this is object P1 and this is object P2. We can see that the object that called the method is printed in the place of self. In these two calls, self refers to object P1, and in these two calls, self refers to object P2. So now we know that Python provides the instance that call the method as the argument for this parameter self. Although you specify this self parameter in the method definition, you don't have to provide a value for it when calling the method. All the methods inside a class should have this first parameter self. We'll see some exceptions later on, but in general, all methods should have this parameter. Python uses this parameter to identify the instance object that calls the method. You can use any other name instead of self, but using self is a convention and it is a very strong convention, so it is better to stick with this name. In the previous lecture, we had seen that classes specify the behavior of instance objects and they define what data the instance objects will have. The behavior is shared by all the instance objects while each instance object maintains its own data. We have added behavior in the form of these two methods, display and greet. Now let us see how to add data. We'll add data in the form of instance variables. We know that in Python, a variable is created by assignment. It comes into existence when it is first assigned. There's no need to declare it. Similarly, instance variables are also created by assignment. So suppose we write here, so this variable name has been attached to instance object P1. This is called instance variable because it is attached to an instance. But this variable has been attached only to P1, not to P2. So if we write here P2.name, we'll get this error. We want all the instance objects to have same variables. So we'll not attach the instance variables like this outside the class. We'll attach them inside the class methods. That way, all instance objects created from the class will have the same set of instance variables. Now you know that inside the class methods, you can access the instance object by writing self. So if you write self dot variable name, then that variable will be an instance variable. It will be an attribute of the instance object. So let's add two instance variables in this class. We'll create a new method here. And here inside this method, we'll create two instance variables, name and age. Now we'll call this set details method for these instances P1 and P2. Let's run this. We'll see P1.name. P1.age is this. So now this object P1 has two instance variables, name and age. Similarly, the object P2 also has these two instance variables. This is P2.name and this is P2.age. So whenever an instance object will call this method set details, it will get these two instance variables attached to it. Instance variables are specific to an instance of the class. Every instance has its own copy of instance variables. Changing the value for one instance does not affect the value in another instance. So let's change this P2.name. Let's change P2.age also. So now this is P2.name and P2.age is this. Let's check the instance variables of object P1. They were not changed. So each instance has its own copy of instance variables and these variables define the state of the instance objects. Now this method set details always sets the name to John and age to 20. We would generally want to assign different values to different instance objects. So to make this method more flexible, we'll add two parameters here, name and age. And now here we assign name to self.name and age to self.age. Don't get confused in the two sets of names. self.name and self.age are instance variables, while this name and age are parameters of this method. So they are just local variables inside this method. You can use this name and age only inside this method, but you can use these instance variables anywhere inside the class. This is because these instance variables are attached with the instance object and they live as long as the object lives. They will not be destroyed when the method terminates, as is the case with these local variables. This dot notation makes sure that there is no conflict between the two sets of names. You can use any other name for these parameters, but it is a convention to use the same names as instance variables. So this name and age are instance variables of the self object, while these two are local variables. Now here, when we call this setDetails method, we'll send two arguments. So now we are able to give different values for name and age. Let's run this. So now this is p1.name and this is p1.age. So the names and ages of p1 and p2 are different. Now let's use these instance variables in these methods display and greet. So here we have written self.name. Now in this method greet, we'll use the instance variable age. So here we have used this instance variable age. When you reference an instance variable outside a class, it has to be prefixed with the instance name and a dot. Inside the methods, self refers to the current instance. So the instance variable name is prefixed with self and a dot. Now let's run this. So we can see the values of these instance variables were used here. So these instance variables name and age are defined in setDetails method and are referenced in these methods display and greet. Now suppose we want to call this method display inside this method greet. When an instance object calls this method outside the class, it is called like p1.display or p2.display. Inside a method, the current instance is accessed by using self. So here we'll call it as self.display. So here we have called this method with self. Let's delete the display calls from here. So from outside the class, we are calling this method greet, and inside this method greet, this method display will be called. Let's run this. So we get this output. So outside the class, the instance variables and methods will be accessed by preceding them with instance object and a dot. And inside the class methods, they'll be accessed by preceding them with self and a dot. So we have seen how to define classes and how to create instance objects. There was a lot of new syntax involved. So in the next lecture, we'll summarize whatever we have studied in this lecture. We define a new class using the class statement. And when a class statement executes, it creates a class object and binds it to the class name. Instantiation of the class creates new instance objects. To instantiate the class, we have to call the class object with a pair of parentheses. The instance object is like any other object of Python. It can be used as an element of a list, tuple, dictionary, or a set. It can be passed to a function as argument or can be returned from a function. Even class objects are first class objects in Python. They can also be passed as argument or returned from a function, can be bound to variables, or used as an element in a container, or can even be attribute of an object. Methods are defined inside the class using the def statement. and they follow all the rules that we have studied in functions. Inside the method definition, the first parameter should be self. You don't have to provide any argument for self while calling the method. Python will automatically assign the instance object that calls the method to this parameter self. This parameter is always required so that we can access the instance variables and methods of an instance object from within the class. Instance variables can be created inside any method by assigning to a variable name prefixed with self. If you have worked in Java or C++, you must have noticed the difference in how these variables are defined. In these languages, these instance variables, which are also called data members, are statically declared. They are a formal part of the class definition. While in Python, they are defined inside methods, and it is possible to even dynamically attach instance variables. To reference an instance variable inside any method, again you have to prefix the variable name with self. To call a method inside another method, you have to prefix the method name with self. So outside the class, we must use an instance object name in front of methods and instance variables. And inside the class, we must use self in front of the methods and instance variables. Many programmers who are used to other languages like Java or C++ generally forget to include self as the first parameter in the methods. If you forget to do this, the interpreter will complain. Let's remove this self from here and see what error is shown. So Python shows this error. setDetails takes 2 positional arguments, but 3 were given. Here we have sent 2 arguments, but it is saying that it received 3 arguments. This shows that Python automatically sends an argument. And so we always need to specify self as the first parameter. And after that, we can have a regular parameter list. So let's put self back here. Another mistake that beginners in Python make is to forget to prefix the instance variables and methods with self. So if you forget to put self here before this method name and run this, you get this error. Name display is not defined. This display is a method of the class, so it should be called with an instance of the class. And we know that self refers to the current instance inside the class. So you need to call it like this. If you forget to use self for an instance variable inside a method, then also you will get an error. So suppose you forget to write self here before this instance variable age and run this, you get this error. Name age is not defined. So you need to prefix all your instance variables with self. Now suppose we define another method. Inside this method, we want to change instance variable age to 75. But again, we forget to put self before this instance variable age. Now we call this method for this object P1. Let's run this and see what happens. We expected an error, but the program ran without any error. Let us see P1.age. It was not changed to 75. Let us see what happened here. An assignment was made to this name age. And we know that in Python, a variable is created when it is first assigned. So here Python created a local variable named age with value 75. And this is why we did not get any error. Now let's write self here. And again we run it. And we see P1.age. Now it has changed to 75. So you need to remember to write self whenever you have to use an instance variable or a method name inside the class.